We are in lesson 3, so we are in money time relationship. So we have here the last topics on the money time relationship, which is the annual cost and capitalized cost and the gradient. So if we are going to discuss this one, okay. So for this, a capitalized cost, that is an application of perpetuity already. It is one of the method used in comparing alternatives. It is defined as the sum of the first cost and the present value of all perpetual maintenance and replacement costs. So for your capitalized cost, it includes there the charges for depreciation. Your depreciation is the decrease in value of any properties. Okay, so it includes also the interest on the money invested, repairs for normal use, so those are the maintenance and the operating costs, and the property taxes and insurance. So we have here also the annual cost. So annual cost is an expense that is added to the cost of a fixed asset, or that is the account or fixed amount. Okay, so there's a difference between the capitalized cost and annual cost. Okay, for the formula of your capitalized cost, that is also equal to your first cost plus the present worth of your operating and maintenance cost plus the present amount of your annual depreciation. So your depreciation there is the decrease in value of a property or any equipment. Okay, so for this one, so if we are going to elaborate the expand the capitalized cost, the formula for that is just equal to the first cost plus the operating and maintenance cost divided by I, which is the interest rate, plus the RC minus SV. Your RC there is same with your first cost and minus the salvage value. Your RC there is same with the replacement cost. So for the salvage value, that is just a book value after all depreciation has been fully expensed. So that is your salvage value. Okay, so for if we are going to draw the timeline for that one. So this will be the capitalized cost. This is the present worth already, and that is the first cost, or that is your annuity, and that is the operating and maintenance cost. And for this one at nth year, that is already your first cost minus the salvage value, and so on. So if we are going to have an example for that, but um, don't forget that your n is, that is the useful life, and for om over I, that comes from the formula of perpetuity, which is a is equal to p multiplied by the interest rate, or that is p is equal to the annual, that is the um, annuity divided by the interest rate. So if we are going to have an example, number 1, determine the capitalized cost of a bridge whose cost of a bridge whose that is 250 million and has a life of 20 years. So your end there, the useful life for the bridge is 20 years. If the bridge must be partially rebuilt at a cost of 100 million, so that is already your first cost minus the salvage value, since it is partially rebuilt. Okay, that is at the end of each 20 years at a rate of 6%. So your 6% there is already your interest rate, since that is annually, and it is not mentioned if it is compounded. Okay, so for the given, okay, for the given, the first cost for that one is 250 million. The operating and maintenance cost, that is of course zero. Okay, it is not mentioned, and since it is rebuilt partially, okay, so that is n is equal to the useful life is 20 years. Next is the interest rate, that is equal to 6%, or that is 0.06, okay, in decimal form. So for the first cost, minus the salvage value, that is already your 100 million, since that is rebuilt partially already, as mentioned. Okay, so for our requirement, of course, we are asked to give the capitalized cost, that is CC. So for the formula of CC, so our solution, okay, CC is equal to first cost plus the present worth of your operating and maintenance cost plus the present worth of your annual depreciation. So for that one, let us have the formulas, that is FC plus your OM, okay, your operating and maintenance cost, divided by your I, okay, plus FC minus SV, which is 100 million already, divided by 1 plus I raised to n minus 1. So this is just like your in compound interest. So I forgot to tell you that your AC is also, your annual cost is also equal to your capitalized cost multiplied by the interest rate. Okay. So having this one, let us compute for the capitalized cost, that is for the first cost, that is 250 million. Okay. Plus 0, since there is no operating and maintenance, plus your FC minus SV, which is 100 million. Okay. Divided by 1 plus the interest rate, which is 0.6, raised to n, which is 20 years, okay, that is the period, minus 1. So our final answer is equal to 295.31 million pesos. Okay, so that is the capitalized cost for the bridge. Let's have here an example. Our second example: a contractor can buy trucks for 800,000 pesos each, or rent them for 1,200 per truck per day. So the truck has a salvage value, or that is also called the trade-in value, of 100,000 at the end of its useful life of 5 years. So your end there, the useful life is 5 years already. The annual maintenance cost, so that is your OM, that is your operating and maintenance cost already, that is 20,000 per truck. So using annual cost method and 14% interest rate, find the minimum number of days per year that each truck must be used to warrant its purchase. So we represent the minimum number as n. So if we have the given, okay, so writing the given, it is for the first cost, that is equal to 800,000. Okay, for salvage value, or that is the trade-in value, that is after the book value after the depreciation, no? So that is equal to 100,000, and for the operating and maintenance cost, that is already 20,000 per truck. That is per truck. And for the useful life, that is 5 years. Okay. And for the interest rate, that is already 14%. Okay, that is supposed to be 14%. And for the rent, so don't forget this one, the rent is equal to 1,200 per truck per day. Okay, so our requirement, sorry, our requirement is we let n be the number of days, so that is equal to the annual cost divided by the rent. So that is in terms of days. Okay, continuing that to be able to get the number of days there. So we have the solution. So it says they're using the annual cost. So if we write that one, your annual cost is equal to your capitalized cost multiplied by the interest rate. So for AC, let us rewrite the formula for your compound interest capitalized cost, which is first cost plus the operating and maintenance divided by I, okay, plus FC minus salvage value or the trade-in value divided by 1 plus I raised to n minus 1 multiplied by your interest rate. So if we are going to substitute the values there for your FC, that is the first cost which is 800,000 plus OM which is 20,000 divided by your I which is 14% plus your first cost which is 800,000 minus the salvage value which is 100,000 divided by that is 1 plus 0.14 raised to 5 which is the useful life minus 1. So that is multiplied also by 0.14. Okay, so we are now ready to get the value of your annual cost. So that is 237,898.48. Okay, to be able to get the number of days, your n there is equal to AC divided by the rent, which is 1,200 per truck per day. So the AC there is 237,898.48 divided by the rent which is 1,200 per truck per day. So we get the reciprocal of day, so the n is in terms of days already. So that is equal to 198.25 days, or that is, sorry, 25 days, or that is also equal to 199 days. Okay, so that is our final answer, 199 days. Okay, for our last example for annual cost and capitalized cost, let's have here example number 3. A company uses a type of truck which costs 2 million with life of 3 years and final salvage value of 320,000. So we denote that one as your truck A. How much could the company afford to pay for another type of truck for the same purpose? Since it is mentioned that it is in the same purpose, we just equate the two trucks there, okay? So whose life is 4 years with a final salvage value of 400,000 if money is worth 4%. So for this one, we denote this unknown as your truck B. So if we are going to tabulate that one, so for the given, we have there your I, which is 4%. Okay, so for the first track, which is A, and then for the unknown, for the second track, that is B, we get the first cost for that. So it says there that the first truck costs 2 million. That is the first cost. And for the truck B, it is unknown, so that is the requirement. So that is first cost of the truck B. Okay. For your OM, it is not mentioned, so that is 0. Okay. For the useful life, that is in N years. Okay. So for your truck A, that is 3 years. So it is mentioned. And for truck B, that is 4 years. Okay, so for the salvage value, that is the trade-in value, it is mentioned that your truck A has a salvage value of 320,000, and for truck B, that is for 400,000. Okay, so for our requirement, so we are asked to find the first cost of the second truck. Okay, so for this one, we just equate the two tracks using the formula for capitalized cost. So for this, let us just denote this one. That is the capitalized cost of the first track, that is equal to the capitalized cost of your second track. So it is we just equate the two since tracks are for the same purpose. So that is your clue there. Okay, so having this one, let us compute for that. That is the first cost of your track A plus OM divided by I. Those are all given. So that is first cost minus salvage value divided by 1 plus I raised to N minus 1. So that is for track A. And for your track B, that is FC, again, that is the unknown, plus OM divided by I, since that is 0. Okay, so plus FCB minus SV, since that is the unknown. Okay, that is 1 plus I raised to N minus 1. So that is for your track B. Okay, so we cancel this one since that is 0. Okay, it is not mentioned. So for the first cost of your first track, that is 2 million, which is 2 times 10 raised to 6. Okay, that is 6 plus, okay, for the first cost, that is 2 million, 2 times 10 raised to 6 minus the salvage value, which is 320,000 divided by, okay, so that is 1 plus 0.04, it is given. Okay, so that is raised to 3, that is the useful life, minus 1 is equal to our requirement, which is FCB, plus 0 plus your FCB, which is the requirement, minus the salvage value, which is given, that is 400,000 divided by, okay, so that is not included, sorry, it's supposed to be here only. That is 1 plus 0.04 raised to 4. So that is already raised to 4 minus 1. Okay, so to be able to compute for the value of your first cost of the second truck, so we simplify this further. That is, okay, so that is 2 times 10 raised to 6 plus 2 times 10 raised to 6 minus 320. 3, sorry, that is 320,000 divided by 1 plus 0.04 raised to 3 minus 1 is equal to FCB. Okay, separating this one, that will become FCB divided by the denominator, or you can directly input that in your calculator. 0.04 raised to 4 minus 1 minus, for this one, that is 400,000 divided by the denominator, which is 1 plus 0.04 raised to 4 minus 1. Okay, so to be able to get the value of your FCB there, let us transpose this one to the left side of the equation. So rewriting that one, that is 2 times x, 2 times 10 raised to 6 plus 2 million minus 320,000 divided by 1 plus 0.04 raised to 3 minus 1. Transposing this one, that will become plus 400,000 divided by 1 plus 0.04 raised to 4 minus 1 is equal to FCB. Okay, we factor this one already, so that is 1 plus 1 over the denominator, which is 1 plus 0.04 raised to 4 minus 1. So to be able to get the value of FCB there, let us divide the whole equation by this one. That is 1 plus 1 over 1 plus 0.04 raised to 4 minus 1 already. Okay, so this is included also. Okay, so our FCB now is equal to first cos of the second track, that is equal to 2 million plus 2 million minus 320k divided by 1 plus 0.04 raised to 3 minus 1 plus your 400,000. That is 400,000 divided by 1 plus 0.04 raised to 4 minus 1. Okay, so that is all divided by the denominator, which is the coefficient of FCB, that is 1 plus 1 over 1 plus 0.04 raised to 4 minus 1. So our final answer is equal to, for the first cos of your track B, that is 2,585,870.437. So that is in peso, of course. So that is our final answer. Okay. All right. So moving on to gradient, let us have this one. Gradient is just a increase of payments. So that is an increase of payments, whether it is a uniform arithmetic gradient or that is your geometric gradient series. So for this one, gradient series is the series of cash flow where the amounts change every period. So that is just the increase of payments. Okay, so having this one, your uniform arithmetic gradient, so the maintenance and repair expenses on specific equipment or property may increase by a relative constant amount each period. So if we are going to draw the timeline there, okay, so that is your present worth, this is your P, and this is your annuity, that is the equal payments. So for the second year, that is added already, the annuity plus the gradient, that is the increase. And for the succeeding years, that is A plus 2G already, and the fourth, that is just A plus 3G, and so on until for the future amount or the nth year, that is just a plus n minus 1 multiplied by the gradient. So if we have here the formula for the future worth of the gradient series, that is equal to 1 plus I raised to n minus 1 over I. So that comes from the formula of the annuity plus gradient over the I, which is your um, interest rate multiplied by 1 plus I raised to n, and then your n there is periods in years, of course, again. So that is minus 1 divided by the interest rate minus the interest period. Okay, so for that one, let us have the example. So don't forget that your interest rate is always equal to your R divided by M, the nominal interest rate, and if it is um, compounded period, so let us just divide it by 2, 4, or and so on. And for the N, that is in years, so we just multiply the compounded period multiplied by the um, periods in years. That is your T. Okay, so having this one example, an engineer receives an initial salary of 60,000, increasing at a rate of 5,000 a year. So the clue here that it is a gradient, a uniform gradient. We have here the increase. Yes, okay. So we have there the increase at a rate, okay? So if money is worth 10%, determine his equivalent uniform salary for a period of 8 years. So this is just a uniform arithmetic gradient, okay? So having that one, if we are going to draw that, so if this is your present worth, this is in years, and if that is your future worth, and this will be the worth of the money. So for the first year, it says there the annuity is equal to 60,000. So that is the first year. And for the second year, since that is the gradient, that is already 60,000. And since the gradient is 5,000, let us just add there 5,000. So that is the second year. And for the third year, that is 60 already. That is 60,000 plus 2 multiplied by the gradient, which is 5k, and so on until we reach n, which is 8 years. So that is 8 years. Okay, so for the seventh year, that is already 60,000 plus, okay, 60,000, that is k, plus, that is n minus 2 multiplied by the gradient, which is 5,000. And for the final year, that is already 6,000 plus 8 minus 1 multiplied by the gradient, which is 5,000. So we have here 8 minus 1, that is n minus 1, same with our figure. Okay, so following that one, for solution 1, since our requirement is the future worth, okay, that is the equivalent uniform salary for a period of 8 years, we have here first the given, that is t years, that is of course 8 years. Okay, for the gradient, that is 5,000 or 5k, and for the interest rate, since that is annually, that is 10%. Okay, so moving on, let us use, okay, so if we are going to use solution 1 for the requirement, we are required to get the future worth. Okay, so for this one, let us have the formula, that is F is equal to A, that is the installment, multiplied by 1 plus I raised to n minus 1 divided by I. Okay, so that is added to the gradient divided by the interest multiplied by 1 plus I raised to n minus 1 divided by the interest rate minus the number of periods, which is in years. So to be able to get that one, let us substitute the values there, that is equal to, which your A there is 60k, that is 60k, okay, so that is 60k multiplied by the given, which is 1 plus 0.1, raised to 8, of course. Okay, that is minus 1 divided by 0.1. Okay, plus the gradient, which is 5,000. That is 5k divided by 0.1 multiplied by 1 plus 0.1 raised to 8 minus 1 divided by 0.1 minus n, which is 8. Okay, so our final answer for the future worth, that is equal to 857,947.69 pesos. Okay, so using our solution 2, since if we are going to use the compound interest, okay, so so using compound interest, that is f is equal to p multiplied by 1 plus I raised to, okay, that should be raised to, okay, that is raised to n already. Okay, so if we are going to write that one, okay, if we have here the timeline, so if we are going to write that, it is also equal to, okay, that is equal to 60,000 plus, if we are to write here from future to the present worth, that is 60,000 plus, we write that one, uh, that is 8 minus 1 multiplied by 5k, so that is the future worth. Okay, so that will be the last, since it has no interest already. Okay, this one plus for the seventh year, that is already 60,000 plus for this one, that is the annuity for that, that is 8 minus 2 multiplied by 5k. Okay, that is multiplied already by the interest. So using the compound interest, that is 1 plus 0.1. Okay, that is raised to 1 plus. Okay, continuing that one, it will give us 60,000 plus, that is 8 minus 3 already multiplied by, okay, multiplied by 5k multiplied by the interest, 1 plus 0.1 raised to 2, and so on. So if we are going to have the summation for that, that is f is equal to, that is from the first year to 8 years. Okay, so that is multiplied by 60k plus, that is 8 minus x. So let us denote there, since this one is increasing, and for this one also it is ascending. Okay, that is 60k plus 8, that is the nth year, minus x, so that is from 1 to 8 already, so that is multiplied by 5k, which is the gradient. Okay, so that is multiplied also by 1 plus 0.1 using the compound interest. So that is raised to x minus 1. For if that is in the first year, if that is 1 minus 1, that is still 0. So that will become and the start of the year, that is 0, that is still 60k. Okay, so that is also equal to, okay, for the future cost, that is also equal to 857,947.68 pesos. Okay, so that will be our future worth. Okay, so we move on now to geometric gradient. So for this one, it is the deposits or payment where there is an increase or decrease by a fixed percentage. So the percentage for this one is fixed and it is mentioned. So that is your clue for the geometric gradient. And if we are going to draw the timeline for that. If this is your present worth, this is your first payment, the annuity. For the second payment, that is just a plus ax, and that let us denote that one as a multiplied by 1 plus x. And for the third year, that is just 1 plus x raised to 2. And for the fourth year, that is a plus 1 plus x raised to 3, and so on until the nth year, that is a multiplied by 1 plus x raised to n minus 1. And your x there is the percent increase, that is the percent increase, or that is the decrease already. So if we are going to have the formula for that one, that is equal to a divided by 1 plus I multiplied by 1 minus w raised to n. So your w there, it is written as 1 plus x, the increase or decrease in percent, divided by 1 plus the interest rate. Okay, so when your w there is equal to 1, your x is equal to the interest rate. So a there is the first payment, of course, g is the arithmetic, and I there is always r over m. Okay, for the x there, that is the percent increase or decrease. Okay, so for example number 1, if we have here a vacant lot has been leased at 20,000 per year with an annual increase of 10% for the succeeding payments. So we have here already the annual increase of 10%. Okay, so that is already geometric gradient. Those are your clues. And for this one, that is succeeding payments. So for this one, this is also your clue, succeeding payments for 8 years. And for the x there, that is the percent increase, of course, that is already the 10%. Okay, payments are to be made at the end of each year, and the interest rate is 7% compounded annually. So your interest rate is your 7%, whereas for your x, that is the percent increase, which is 10%. That is compute the present worth of all the payments. So if we are going to draw the timeline for that, if this is your present worth, okay, so that is until 8th year, so this will become your future worth there. And then this at the first year, that is 20,000, 20k for the second year, that is already 20k multiplied by 1 plus the percent increase, which is 0.1. Okay, so for the third year, that is 20k multiplied by 1 plus 0.1 raised to 2 already, and so on until we reach the eighth year, that is 20,000 multiplied by 1 plus 0.1 raised to 8 minus 1 already. So for the given, let us just write it here. The annuity, that is 20,000, that is the first payment. The I, that is 7%, that is at M is equal to 1 since that is annually. The percent increase, that is 10%. Okay, for the T years, that is 8 years. And for the requirement, we are required to get the present worth for that one. Okay, so for using solution 1 again. Solution 1 using the formula given, that is P is equal to A divided by 1 plus I multiplied by 1 minus W raised to n divided by 1 minus w. And since the w there is equal to 1 plus x divided by 1 plus I, let us compute for the value of w there. So we have to have the exact value for w. Okay, so or if you can store that one to a, it's okay. So 1 plus your x, that is 0.1, divided by 1 plus 0.07. Okay, so computing that one, it will give us the exact value, which that is 0.028037383. Okay, that is the exact value. We use the exact value for W, or you can store that using your calculator. Okay, store that to A or store that to B. Okay, so writing that one, that is P is equal to 20,000, that is given, the annuity, divided by 1 plus I, which is 0.07, multiplied by 1 minus 1 point, um, okay, that is 1 minus 1.028 and so on, divided by, so that is supposed to be raised to 8. That is raised to 8. So getting the exact value for W, that is 1 minus 1.02803 and so on. Okay, so our P, our present worth, that is equal to 165,058.80 pesos. So that is the present worth for that one. Okay, so using solution 2, if we are going to use compound interest again, so P there is equal to F divided by your 1 plus I raised to N. So if we are going to rewrite this one, it will give us, for the first year, of course, that is 20,000. Okay, the present there, the present worth is 20,000. Okay, 20,000 divided by 1 plus 0.07 for the first year. 7 raised to 1, since that is the first year, plus, okay, that is already 20,000 for the second year, that is multiplied by 1 plus 0.1, since that is already the percent increase, and we raise that to 1. Sorry. Okay, so we raise this one to 1, since that is the first year, divided by, okay, for that one, that is 1 plus 0.07 raised to 2 already. So that is the second year, plus, okay, so for the for the third year, that is 20,000. So don't forget the thousand there. 20,000 multiplied by 1 plus 0.1, the increase, 0.01 raised to already, that is to 2. Okay, so that is ascending again, so that is 1 plus 0.07, since the year is ascending also, that is 3, and so on. So if we are going to write this one in summation form, that is the summation. Okay, that is the summation of the first year until the 8th year, multiplied by the compound interest, which is 20,000, multiplied by 1 plus 0.1, and let us denote the years in x. So that is supposed to be minus 1, since if we are going to substitute there 1 minus 1, so that is 0. So it will become 1. So a number raised to 0, that is still 1, and we come up to this equation, that is the first year. Okay, so that is divided by, okay, so that is 1 plus 0.07. Let us denote the years again to x. So that is the limit for that one, is from the first year until the 8th year. So our answer is still the same. That is the present worth. Okay, for your P there, it's the same. That is also 165,058.80 pesos. So the answer is the same. So we have to use the exact value of the W, so that we may come up to the same value. Okay. Okay, so having this one, our last example, a girl borrowed 120,000 from the bank and promised to pay annually for 5 years. The payment at A pesos, that is the annuity, she intends to double her payment at the end of each successive year. So that is successive payments again. So the clue here is double her payment, since doubled, that is already your x, that is plus 1, so that is 2 already. Okay, that is 1 plus 1, or that is equal to 2. Okay, so given that the interest rate is 8% compounded annually, so your I there is already 8. Since your m is equal to 1 already, find the amount of the first payment. So we are asked to have the present worth for that. Okay, so if we are going to write the number line for that, the timeline, this is the borrowed, that is 120,000. So in the first year, that is just your first payment, and then for the second year, that is a multiplied by 2, since that is doubled, or we can write that one as a multiplied by 1 plus x. Your x there is still 1, since that is doubled. Okay, so that is the second year. For the third year, that is a multiplied by, multiplied by 2, that is multiplied by 2, that is raised to 3 already, that is 2, sorry. So if we are going to rewrite that one, that is supposed to be 1 plus 1, since double, that is x is equal to 1 raised to 2. Okay, so that is for the fourth year, let us all write it. Okay, so that is a multiplied by 2 raised to 3, or we can write that one as a multiplied by um, multiplied by 1 plus 1 raised to 3. And for the fifth year, of course, for the fifth year, that is your fifth year already. Okay, so that is a multiplied by 2. Let me just adjust that one. That is multiplied by 2 raised to 4, or we can write that one as a multiplied by 1 plus 1 raised to 4. Okay, so if we are going to have there the given, okay, so the given there is your t, which is 5 years, and for the present worth, that is 120k, that is the money borrowed. For your m there, that is 1, so the interest rate is the same as 8%, and the requirement, that is a, that is the first payment. Okay, so using solution 1 again. Wait, let me just adjust this one. Okay, so for solution 1, let us have the formula again. Solution 1, solution 1 using the formula, which is P is equal to A divided by 1 plus I for geometric gradient, that is multiplied by 1 minus W raised to N, the exact W, minus 1. Okay, so that is our W there is 1 plus X divided by 1 plus I. Okay, so substituting the value there, since that is the X here is 1, that is 1 plus 1 divided by 1 plus 0.08. So the value of your W, which is the exact, or you can store that one, 8518 518 852. Okay, so rewriting that one. Okay, so your P there is 120,000 is equal to the first payment, which is the requirement, multiplied by 1 plus 0.08, okay, multiplied by 1 minus 1.8518, and so on, divided by 1 minus 1.8518, and so on. So our A there, if we are going to compute for that, that is also equal to 5,313.14 pesos. So that is our final answer. So that ends the lesson 3, that is your capitalized cost, annual cost, and the gradient, the uniform arithmetic gradient, and the geometric gradient.